So today we're going to be talking about linear systems. So we'll be doing an activity on Desmos and we'll be talking about what is a solution. So the first thing I want you to do is read through this problem. It says a recreational vehicle dealership sells both mopeds and ATVs. Before a big sale, one of the workers was tasked with cleaning all 200 vehicles. As the worker cleaned, he counted there were 698 tires. How many of each type of vehicle are there at the dealership? So we could go through and puzzle out and figure out this answer by guessing and checking. But I want you to see if you can come up with the answer and see if you can come up with a fast way to get there. So take a moment and pause the video and see if you can figure out how many of each type of vehicle there would be. A little word in case you're unsure of what these are. A moped would be a vehicle with 2 tires because it's kind of like a bike. And an ATV is like a 4-wheeler, and those would have 4 tires. So see if you can come up with how many of each type of vehicle there would be. Pause the video and see if you can find it. All right, so the next piece of this would be you're going to be working on what is a solution in Desmos. So you can either use this code here or you can use the link on the bottom to go to what is a solution and learn about what exactly do solutions look like in a system. Take a moment, pause the video, and go through that. It should take you about 20 to 30 minutes to do. Okay, so ideally you've finished the what is the solution activity, and you've kind of learned about what exactly a solution is. Basically what we're talking about in this chapter is called linear systems, and quite literally that just means a group of linear equations. And the solution to a group of linear equations is where do those equations cross. So like in this case, our solution would be this point right here. So if I asked you to find the solution to this system, you would tell me the point 2, 4. In this first part, we're going to be talking about how to find the solution to a system using graphing. And then we will also be talking about how to use something called substitution. And later on, we'll be talking about something called elimination. If I'm being completely honest, these two will be far more popular than graphing, but we start with graphing because it's a little bit more familiar to us and we talk about what exactly does that solution mean. So we'll start with this example. So it says y equals x plus 3. So in case you forgot how to graph a line, the first thing that you want to do is start with your y-intercept. So in this case, our y-intercept is at -3. So that means I start at the -3 on the y-axis here. Then my slope tells me how do I get to my next point. So in this case, my slope is -5. What that means is that I would go down 5, 1, 2, 3, 4, 5, and then over 1. So we've been talking about slope for quite a while now, so hopefully that's familiar to you. Now that you've got a slope in there, and you've got 2 points, I would add 1 extra point just to make sure your line is going to turn out nice. And I like to go backwards. So this point was down 5 over 1. I'll go backwards and up 5, like that. And you could continue the pattern if you wanted to get to this point. But now that I've got some points in there, I would graph my line. Now you would want to use a straight edge because that looks a little bit yucky and a little bit difficult to understand. Then we would graph our other line. So this one is at x plus 3. So I'm going to start at +3 because I have a +3 as my y-intercept. And my slope, even though there's not a number here, we're allowed to assume it's 1, which means that I go up 1 and over 1, like this. Once I've got my points in there, I would draw a line. You don't want to draw a dinky little line right here in the middle. You want to make sure your line extends across the graph. So now that we've got our two graphs on the plane, what we're looking for is what is our solution? Meaning, where do they cross? So in this case, my two equations cross right there at that point. So this point of -1, 2 would be our solution. So in case you're stuck on how I did my graphing, the second number, like we've been talking about, is our y-intercept. That means where does the graph cross the y-axis? So since this case was -3, I start at -3. Then the number in front of the x tells us our slope. How do I get from one point to the next? So I start at my y-intercept and I use that slope to get to my next point. So in this case it was -5, meaning go down 5 and over 1. And in this other case, the blue line, it was a +1. So starting at my y-intercept, I went up 1, over 1. So we're going to try again. You'll notice that I use different colors for the graphs. It just makes it a little bit easier for me to keep track of what I'm doing. So I'm going to do this one in pink. Our y-intercept is at -5 and has a slope of -2. So from this point, I'm going to go down 2 over 1. Like I said, I like to put in a couple points just to give me a better idea of what this line looks like. And then I'm ready to draw my graph. Okay. Now we will go over and graph our other line. So this one has a y-intercept of -2, so that would be right here, and a slope of -1/2. Now that means I go down 1 over 2. Don't forget that fraction. The numerator tells us how far up and down. The denominator tells us how far side to side. So like that. Again, make your lines nice and big across the whole graph. And our solution, like we said, is where they cross. So in this case, they cross right there at -2, -1, which would be our solution. Now when you write out a point, you always want to put it inside parentheses like that. So that's our answer. Okay, so you're going to head to the Delta Math Complete Solving Systems by Graphing activity. That is going to be your homework for this evening. So when you are done with that, make sure that you are comfortable with graphing, and if you need a little bit of help, don't forget that there is that Watch Help video inside of Delta Math on the upper left-hand side.